So please go ahead.
Okay, well, thanks very much, Dr. Vidula. Welcome, everybody. Thank you very much for taking some time out to watch our presentation. My name is Carlo Manfredini. I'm the R&D Director for Emona TIMS. And as you can see on your screen, we've been manufacturing teaching equipment for 25 years. What I'm planning to do in this 1 hour is quickly give you an overview of our company for probably 10 minutes. And then I will go live to the equipment that we can try out and I can demonstrate, and you can log in and use the actual equipment as if it was your very own. So we'll start right away and we'll get moving. So Emona Instruments, we're based in Sydney, Australia. Everything that you'll be seeing tonight is coming to you from Australia. So it's a live test of real remote engineering. We've been around for many years and we're now in over 400 universities around the world. And our philosophy is that technology changes, of course, all the time, and yet the principles remain the same. So when we teach the principles, we know that our students will become very well informed as opposed to merely teaching how to use technology. As you can see, we've started from smoke signals, valves, transistors, integrated circuits, and who knows what the future will bring. Moving right along, our philosophy here at TIMS is that we try to teach the mathematics. We want the mathematics to come alive. So in telecommunications, for example, the maths is represented by a block diagram. The block diagram can be emulated or modeled by some hardware modules. Each one of these modules is an individual block in the block diagram. So I can show you here, we have a multiplier block, we have an adder block to the left of the oscillator. There are very many blocks, so the more blocks you have, the more systems that you can build up in a hands-on manner. We're very much dedicated to hands-on teaching. So using this modelling approach, we're able to build a complete transmission system, encoding, modulation, channel, demodulation, and decoding, which is what we have been doing in the telecommunications sector for many years. Because this system is modular and very adaptable, with the one system you can do very many modulation schemes. And I will just quickly breeze through this list. Please don't try to read it because it's all on our website. So basically we have three aspects of products in our range. We have hands-on hardware, remote hardware, which I'll be demonstrating tonight, and simulation, which is obviously complementary to these other two modes of delivery. We look at hands-on hardware, we have our wireless communication trainers, we have our smaller, more portable units. Then, of course, we have simulation, where we have a simulator which has got no programming involved. It's very much what you see is what you get GUI, so students don't have to waste their time learning syntax when they could be learning the principles that they're studying. And finally, the third rung of our products is the remote control experiments. Since 1999, we've been making a product called NetTIMS, which is our telecommunications trainer controlled across the internet. And it is basically one of our standard units with modifications so that all the experiments can be manually controlled by each student individually across the internet. Multiple students at once can conduct the experiment. And tonight we'll be having a look at that live from Australia. And also tonight I'm going to be highlighting a new product range which we call Net Circuit Labs. This is where we have electronic circuits which are also delivered across the internet to multiple students at the same time. Multiple students, 30 or more students, can log in and conduct electronic experiments of which there is a range to select from. So this is indeed a breakthrough in teaching from the remote aspect. So if we have a look at our entire product range, we have our telecommunications units, we have our simulation, and on the right, what we'll be focusing on tonight in the next few minutes is our remote access telecoms labs and our remote access electronics labs. So let's go into this area and look at blended learning solutions. So blended learning is now the idea of the flipped classroom, where we have an on-campus and an off-campus scenario. In the past, we had on-campus, we had lectures, we had in the lab collaboration, and we had simulation in the lab. Off-campus, we are now all aware of YouTube and self-paced video instruction. We, of course, still have simulation, which is very useful for preparing for the lab. And as well, we have remote labs, which some people call them virtual labs. We prefer to call them remote access labs, real circuits at a distance. And we believe that the collaboration of on-campus and off-campus gives students and hopefully lecturers the best of both worlds. So right now we'll be presenting our remote electronic circuit labs. So here's a diagram showing basically what we're offering. In the middle, you have your unit. It is actually a physical unit that will be located in your laboratory, in a room connected to the internet. And students either at home across the internet or in class across a local area network, any time of the day and from any location can access these labs. Many students at the same time, all using the one unit. So let's just discuss the benefits of this revolutionary system. One piece of equipment can cater for 30, even 50 students at a time. It's available 24 hours a day, 7 days a week, all year. Extreme flexibility for your curriculum. It saves cost, it saves storage space, it saves handling and inventory, it increases lab access time, which increases learning. And it's supplied ready to use. You just unpack it, enter your IP address, and start delivering the labs straight away. So here's a diagram of how the system is structured. You have your experiment platform on the left. It connects to your LAN. You can have multiple users on the LAN, all accessing that one IP address. And you can have multiple users across the internet, all accessing that one IP address. And best of all, it's controllable from your browser. There's no software to download. It's all executed in HTML5 via your modern browser or tablet or laptop. So some of the functionality that we have built into the system is you can select one of many experiments on each board. So each board is an entire lab covering a topic with multiple experiments. You can control the switches. You can open and close switches remotely from your browser. You can move potentiometers, individual circuit elements. You can drop and drag with your mouse. We'll be demonstrating that. You have a fully variable function generator, variable frequency, amplitude, multiple waveforms to choose from. There is no VPN required. There is no TeamViewer software. It is all direct into the browser. And so the unit looks pretty much like I've shown. Individual boards are plugged into the top of the unit, which contains a server, and connect to the LAN. So here's a photograph of our workshop downstairs where we have 4 units connected to the internet at this very moment. They're all on the same IP address, but with a different port number. And units, and you can ask some questions and we can explore the capabilities. And as you can see, they're very well self-contained. They don't take up much space, and each one of them has a different board plugged in. So you want to deliver a different topic, you plug in a different board. Or if you wish, you can use one unit and replace the boards every week or every day by simply plugging in the board that you require. So I'm going to demonstrate it for you at the end of this presentation, which will just be a few minutes on these IP addresses. So in a few moments, we'll come back to these IP addresses. But as you can see, it's one IP address and multiple port numbers to access all these different laboratories. So we'll be coming back to this screen in a few minutes. First of all, let's have a look at one of our boards. This board delivers the op-amp circuit experiments. Now, if you look at this board, there's a number of circuit blocks. Each one of these blocks is a different circuit, and the large chips on the board are digital potentiometers and electronic analog switches. So we're able to control all the variables electronically. For example, here is one of the blocks, dynamic range experiment, and here is the screen that the user will get in their browser. They have the interactive circuit. You can click on the switches. They have a full scope and they have function generator inputs, and multiple users can use it at the same time. Here's another example, the differentiator experiment. There really is no limit to what you can teach with this system once you have controllable switches and controllable potentiometers. This is the menu of the lab manual that comes with the system. Here we have a small sample of experiment layout, step by step. Now finally, the second board, this is a transistor circuits board, which delivers 6 transistor circuits. Same sort of construction, multiple experiments on the one board, which you can deliver. Multiple experiment panels, which are loaded interactively from your browser, and different students can do different experiments at the same time. They're all completely independent of each other. At the end of this presentation, I'll stop for a brief question session. So please prepare your questions before we go into the demo. The third unit we have is a digital logic board. Now this is a digital logic lab which delivers a large number of digital logic experiments. In fact, the entire introductory digital logic course. Of course, they're all implemented in an FPGA, which is underneath this red Perspex cover. And the digital logic functions that we have implemented in the FPGA, which are fully controllable by the student. You can see there are signal sources, there are many, many gates and flip-flops. And so students no longer need to suffer the indignity of the switches being broken and breadboards not working and soldering not working, because that really is an electronic construction issue when they want to really study the principles of digital logic. So no longer do we need to have this kind of arrangement, which is fun, but is very time consuming and not that practical these days, when instead we can have something like this. So here we have a visual of a number of gates that have been wired up to implement a function, and you can see the scope down here. So in a few moments we'll be trying this for ourselves independently. So much more easy to use and interactive. As well, with the digital logic laboratory, the students can place the logic gates anywhere on the screen and wire up the experiment for themselves. They just choose from a menu of logic gates, and they're able to construct an unlimited number of experiments according to the textbook that you might be studying. And finally, the fourth board we have is a remote circuits breadboard. Because our system has available remotely controllable pots and remotely controllable switches, we have a board where you're able to build your own circuits and have them controlled by our infrastructure and deliver your own circuits to the students so that you can cover any topic that you're interested in. So for example, at the moment on the system that we'll be looking at, I have 2 simple demonstration circuits. I have a triangle wave generator, and I have some RC, switchable RC circuits that are implemented. And what basically happens is the student knows which one of the terminals they want to connect to because they have a graphical schematic, and they just control each one of the pots themselves. So this way it's flexible and adapts itself to your particular needs. So that is in summary 4 of the labs that I'll be demonstrating today. And so at this point, I would like to just pause briefly, and now 15 minutes has elapsed, if there are any questions, if anyone has passed any questions through.
Okay, okay, everybody. Questions coming up. So if you have any questions, let us know. We have a couple of minutes. We haven't got too many questions yet, but I'm sure there will be others. A question here: Can the learning that happens during the real lab experiments, that like solders, it's not right, or components not working, etc., can those also be simulated? Some mistakes. I mean, can you simulate the mistakes?
Yes, very much so, because at the end of the day, the student has to adjust the variables, the potentiometers and the switches to implement the correct operating point of the circuit or the right gain of the circuit. So there are very many parameters that the student still has control over, but in most cases they don't have control over the wiring because that is fixed for a circuit, but they have control over all the parameters. Having said that, with the digital logic, they have complete control over everything. So they're free to make as many mistakes as they need to.
Okay. All right, please go ahead. I'm sure questions will come in a little bit later. Yeah.
Fantastic. All right. So now let's open up so over here on the right, I have the IP addresses. And first of all, I'm going to open up the op-amp circuits page. So I don't know if everyone can see that, so I'll read it out. I'm opening up address 202.129.82.254:3333. Okay, so this is the front door of the server, which we have downstairs here in Sydney. You can access it with Chrome or Firefox or a very new version of Internet Explorer. There we go. So for this demonstration, we have created a unique username and password, IUCEE. So I'll just enter that. And everybody can do the same if they wish.
Yep, on your own screen, you can start entering on your own. Yeah.
I'll submit. Okay. Right, so now I have a screen. I have one of the experiments on my screen. And over on the left, you can see currently we have one user. That's me. And I'm able to look at this experiment, but let me look at what other experiments I have to choose from. I click load, and I can go to the menu of experiments. I have dynamic range, open loop, in-out voltage, common mode, inverting amp, follower, summing, differentiator. So let's jump down to maybe duty cycle. Okay, now there is a duty cycle, and down the bottom you can see the oscilloscope screens.
Somebody else has joined you. Somebody else has joined you. 2 users now.
That's great, 2 users. And they can do this experiment or they can do their own experiment. It's up to them. You can move the leads by just moving the elasticity knob, get them out of the way. Okay, so now you can see 4 different points, and I can move my points. I'll select channel B, and I'll move channel B. I'll select the purple channel, and I'll move it to him. So I can move my scope points all around the circuit, but as well I can change the potentiometer. So now I'm going to go to the potentiometer that I'm circling here, variable resistor 10K. I'm going to click, and I'm going to drag it down. And 1.5 seconds later, the circuit has changed. The signals have changed. I'll drag it a little bit more. And as you can see, the signals down here are changing. I'm able to change the time base. I'm able to investigate the signals more carefully with cursor movements, taking measurements, etc. So you have a fully functional 4-channel scope and fully functional control over the parameters of the circuit. So let me go to a different circuit, perhaps sine wave generator, drag this like this, drag this one like this. So the student would be following a procedure and paying close attention to the signals, taking measurements, quickly changing voltage scales, etc. You can trigger on the scope, etc. And so, as you can see, fully functional in the browser, very rapid interaction with the hardware. So I don't know what kind of latency you're experiencing there in America or in India, but here in Sydney, I'm experiencing across the internet less than 1 second latency from when I click to when something happens. Now, let me explain one thing. Some people may be wondering, how is it possible that this system can share itself with so many users? The reason for this is a single-shot digital scope. So when I click, I'm presented with the data that from the circuit, but when I'm not clicking, the system is available to other users. So the server shares itself with other users. So in that way, we're able to time share the unit, 30 to 50 users at the same time. So that explains how we do it. You know, naturally, there's only a certain amount of real time, and it's allocated to all the users. So now what I would like to do is move on to a different experiment platform. So I'll go on to 222. I'm going to enter. I'm going to enter in the same username and password. So these systems are running 24 hours a day. So if any time after this demonstration you'd like to use the equipment, please just log in. We'll keep this username and password valid for a couple of weeks, and you can experience the system yourself. Now here, I'm going to play around with a function generator. So I'm going to increase the amplitude. Okay, you can see the signals are getting a bit bigger as I increase the amplitude. I'm going to select a sine wave. Or maybe I'll switch to a triangle wave, you know. I have a lot of options. And now you're asking about, can the students make mistakes? Very much so, because here you can see the signal is saturating. So the student needs to think about what's going on with the operating point. They have to make changes to the circuit, take measurements as they experience all the different circuits that are available in this system, dropping and dragging. And so if the circuits are not something that you're interested in, you can always build your own circuits. So with this lab, we're able to deliver 6 different experiments: AC amplifiers, feedback amplifier, differential amplifiers. I'll just click and show them. Feedback amplifiers, SCR circuits, unijunction transistor circuits, and OTL power amplifiers. And as you can see down here, we have users. At the moment, I'm the only person using this experiment, but other experiments might be being used by other users. Okay, so that is the second box that I showed you in the presentation earlier. So now we'll go to one of the more fun ones, the digital box. And it's fun because the students get to control everything themselves. So let's go into port address 1111, IUCEE, IUCEE. In we go. Okay, so here you're presented with a blank screen. So what we will do here is click on select and choose what we would like. So I'm going to choose a binary counter as a signal source, inputs on the left, outputs on the right. Then I'm going to choose one of my favorite modules, which is the gate medley. A gate medley is a combination of gates. This is a great introduction for students. So first of all, I'm going to look at my input signal. I'm going to look at my input signal like that, and I'll move the blue channel down. And I might even turn off the channel C and D so they don't get in my way. Now I'm going to wire up. Now these are real hardware. This is not a simulation. This is real hardware implemented in an FPGA. Actually, now I'm going to turn this back on again because I want to use this channel. I'm going to look at an AND gate. I'm going to change my voltages. It all takes very, very little time. And there you can see the AND function of the blue signal ANDed with the red signal gives obviously a gated function. Now we're on channel D, I might look at, I don't know, maybe exclusive OR, see what that looks like. Oh, so it's off. I need to turn it on. Okay, very good. So now look at that. Okay, so now we've got an exclusive OR function, and you can see the signal is inverting whenever the red signal is high. The exclusive OR acts as an inverter. So let's expand this a little bit so you can see a little bit more clearly. There you have it. So that is how students can interact. Here's another interesting thing you can do to show that this is real hardware. Let's put an inverter on the screen and let's see what happens when we connect an inverter, its input to its output. So I'm going to connect this output to its input. And there you can see, as you would expect, the hardware inverter is oscillating. Let's change the time base. We have to go right to the very end of the time base. Okay, and there you can see the inverter is oscillating at 1, 2, 3, 4, 5 megahertz. Let's just use the frequency spectrum display, which is enabled on the scope. And you can see my pointer is indicating 5.98 megahertz on the spectrum analysis. I'll turn that off. Okay, so there's an interesting example of the real hardware aspects of this system. And finally, with this system, because wiring up experiments takes some time, it's possible to just load experiments that have already been wired up. And students can load and save their experiments to the server, and the professor can load and save experiments to share with the students. So now I'm going to load an experiment which is a finite state machine. Okay, now this is quite an elaborate circuit. It's a finite state machine, which is a non-trivial circuit, and hence there's a fair bit of wiring, but it's certainly not as hectic and unmanageable as using a real breadboard. So students can study this circuit, make some changes, you know, wire it up differently, please themselves, and and save, as well as anything else they would do with a real system. Okay, so that is our third unit, which is the digital logic board, and I can change that. I can load the blank template again and place flip-flops or numerous flip-flops, NAND gates, etc., etc. There's a wide selection of gates, not an infinite selection. There's just enough so that you can do everything in a basic introductory digital logic textbook before you then go off and study FPGAs and DSP, all that kind of thing. All right, so now the fourth unit that we have connected is the breadboard that I spoke about. It's at 202, 129, 82, 254, 555. Let's log into that. Once again, I use CEE. Okay, so now we have basically simply the control elements. So you need to see what is the circuit that's been implemented. Because it's your own circuit, we don't know what it is. So we have the facility here for experiment overview. So down here in the bottom left corner, I'll click on experiment overview. It will open up a PDF file which you have prepared and loaded into the server. Okay, and this shows you, I'll just pull it over here into a different window. So this shows the student what the circuit is that is implemented here. So you can see some RCs and a triangle wave generator, which is controlled by RV1, RV2. I'll come back to my screen. If I had a bigger screen, I could look at both things at the same time. I will drag RV1 and I'll watch my signal change. Obviously, because I'm not following an experiment procedure, I'm just randomly doing things, but a student would be following the experiment procedure according to the documentation that we provide or that you write for yourself. Okay, so there you can see almost instantaneously the circuit that you have built on a breadboard, which we have downstairs, is changing. It's via my browser. So I'm changing the resistors, the circuit is responding, I can look at multiple points around the circuit, etc., etc. So that's as easy as the interaction is for the student. The student just clicks and drags and studies the real signals according to the theory. So the final demonstration I'd like to do is the telecommunications system that we also have connected up here. So this is located at the same IP address, but at a subdirectory nt5.html. And you can get to this from our website, imonatims.com. So it's easy for you to try this out for yourself. We have it in English and Chinese. We could also have it in whatever language you wish, because it's HTML5, it's easy. Once again, we'll log in. This time I'm logging in with the password user visitor, which is our standard login password on the website. So you'll see that documented. Okay, now here what we have is a different looking system, because this looks like our TIMS unit. This system looks very much like the TIMS unit that we typically, which I discussed earlier. Individual hardware modules, which are controllable by the end user. And here we're delivering a quite complex signals and systems experiment. I can change the gain. As you can see, things are changing. I'm changing the tuning on the modular tunable low pass filter. So this system is also fully changeable by the professor, so that you're able to deliver hundreds of different experiments to your students in telecommunications and signals and systems remotely across the internet in real time. So as you can see, since 1999, we've been making these systems. They're very efficient now, and we're able to cover a lot of topics. And in the near future, we'll be introducing more topics. So if we have your email address, we can keep you informed as to the new topics, like a fully switchable telecommunications trainer, etc. Things like that, which will enable you to deliver all of your labs. So this is not designed to replace your labs. This is designed to complement your labs, because naturally students need to come into the lab to have some hands-on experience. But it would be really great if they could get some work done in their own time away from lab, so that they can be more productive in the lab, so that they can learn more in their own time, and so that they can have a better understanding of the principles of electronics, telecommunications, signals and systems, etc.
That's a very important point that you make. It's not meant to replace the labs, but it's a supplement, because most colleges will have some equipment, but this will give them a wider range, and also the ability for students to use this when they're in different locations, and not just when they're on the campus. That's really good. Yeah.
Exactly, because of course we don't want to eliminate labs. That's hands-on, but blended learning and flipped classrooms suggest that students can get a lot of work done in their own time and on their own premises. So now we're able to enable that, and other providers that do webinars are also showing how you can control motors and other pieces of hydraulic equipment, etc., etc. So the whole field is opening up in a very exciting way. Like I say, we've been making this since 1999, and these units are now ready to ship. We're starting to ship them around the world, and as we add more labs, they gain in popularity. So I'd like to just open up the floor to any more questions, or perhaps I can help.
What I'm going to do is, in order to prompt a little discussion, I just want to get a feel for the audience through a couple of poll questions, maybe wake them up a little bit, and might trigger some thinking. So I'm going to ask them. One question I just prepared is, whether they are currently using any virtual labs, because in India, there are some. The government has a virtual labs program, and there's some things have been developed, and colleges might be doing some things on their own, in their own way. So I'm just going to put up a poll for all the audience and say, are you currently using any virtual labs in your teaching? Three options. Yes, very often. Second is sometimes, and no. So I'm going to launch this and see what kind of response we get. And it's also a way to see if our audience is awake. Okay, so let's see what they do. Okay, so we're getting some responses, which is good. Yeah. Okay, let's see some more action, guys. You can do take this poll wherever you are. Whatever system you're working on. Some of you might be using iPhones, some of you might be on computers. But let us see some action here and get some results. Let's get some idea what. I'll leave it open for another 10-15 seconds and see what you have to say. And maybe those of you who are giving some positive responses, maybe you can text telling us what type of virtual labs you're using. And so I'm going to close right now. We've got most of you have come in, and so the sharing the results. It says that it's about it's interesting. So exactly 33, 33, 33 for all the three options. So 33% of them never dealt with virtual labs before. 33% of them has said quite often they use virtual labs, and 33% said sometimes. So please, I mean, those of you, particularly those who are saying very often, I'm curious to know what exactly are you using and how effective they've been. So you might want to start a little discussion about that, because this is all in the context of overall improving the quality of our teaching and learning. So let me quickly put up another quick thing which is a little more relevant to this particular this particular presentation that we had. So I'm going to ask you, do you see the benefits of these kinds of labs that has been presented today's webinar of value to your teaching? Do you see yourself exploring some more how to what's involved? Because I see several of you, 3-4 of you have actually played around, so joined as users. So let me just get a sense of how much interest there would be in following up on this webinar today, and trying to do a little more in-depth the helps and assistance and discussions involved in moving forward in this area. So the question is, do you see, from what you're hearing today, do you see some benefits to working with Emona, and seeing if something good can come out of your of this webinar in each of your own experiences? And so I'm getting again some good feedback. So let me just see. Okay, so a couple of questions have come up. We'll read that also. Okay, so we have. I'm going to close this poll and show you the share. So this is good. I think about 83% of them said yes. We would love to. That they would see some benefits from using what you're shown today in this webinar from Emona, and 15% say maybe. So that's an overwhelming response saying that hey, something they learned something today that they might be able to use. And so let me just read out very quickly one or two questions, and then maybe you can hand it over to you or anybody else from your team. I think I noticed there's several of you from your team here. You have Alfred and you have Sinoj as well. May want to, I can unmute them, and maybe they can chat a little bit about what experiences they've had with the colleges in India, because I know they've been running around, and they were at the conference last January giving workshops and so on. So let's have some idea what is the potential, because we'd love to work with Emona. Obviously, would love to work with Emona and see where can we take all this and really benefit the people that are in your classrooms. So let's see the questions. Okay, can the learning that happens during real lab experiments be also simulated? So I guess the question is, your real lab and simulation. You understand the question?
Yes, excellent question, which I haven't covered yet. What we believe is that a very useful part of blended learning is to have simulation running alongside your remote access lab. In fact, what we would encourage is for you to open up a window of, say, Multisim Live, and then open up the remote lab and compare the signals that you get from a simulation with the remote lab circuit. And in fact, to enable and support this type of comparison, we supply Multisim Live circuits online for you to immediately load up and look at, because we believe that simulation alone is not enough. We think simulation's terrific, but simulation doesn't give you real-world signals. It basically gives you textbook-like signals, but not real-world signals. So it's very educational to have a simulator window open up alongside the remote access lab window. And for that reason, on our website, we'll be providing access to multi-sim live circuits.
Can you and your team share some experiences you've had within India, because that's there's so much potential. What have you all seen when you go around, and what kinds of issues have faculty raised and their fears or their excitement of using this, and of course the $1 million question: what is the approximate investment that the college has to make in order to be able to tap into resources that you have provided? So if you maybe chat a little bit about that, it might provide some some insights to the folks that are here with us.
Great idea. Thank you, Dr. Vidula. So yeah, when I was in India just recently at the workshops, people were very excited that this was available off the shelf, that it could solve their inventory and their time sharing crisis. They were also concerned that it doesn't replace real hands-on, which is important. They're also interested in being able to deliver their own personal experiments, which it can do. So we felt that it was a good complement, and people were receiving it really well. Since 1999, we've been selling remote labs to all parts of the world. Some users use it when they can't come into the university because there's a war going on in Syria or something like that. Another uses it on a local area network so they can have 60 students doing the lab at the same time, something they could never afford. So the cost proposition at the moment is, and I can't give specific numbers, but basically what you would do as a university is you would purchase the unit, you would have the 1 or 2 units on your campus, it would be yours, and you could share it with whoever you want to share it with, because we have a password protection on the server. So there is an administration page which you can control yourself. So you buy the unit, you have it on your campus, and you share it and schedule it with whoever you want to use it. Now, people can use it at any time. It's multi-user. So you can say, on Monday, I'm going to let all the students from class 1A use the equipment. And then on Tuesday, I'm going to give access to all the students from my other campus, and et cetera, et cetera. So basically, the cost proposition, it's great value because you're sharing it with all your campuses and with all your classes. In terms of having an exact price, it would be simpler if people could just contact us on our website, and we'll send you a proposal. Our distributor in India will send you a proposal.
Where have you had the most success in India? Any particular college that you want to mention, or is that something you would prefer not to share?
I'm actually in sales myself. I know that IIT Delhi and other campuses, other IITs use our equipment. Perhaps Alfred might come and inform me as to if he can hear this. He might send me a message. But otherwise, we've had success in a lot of countries. I can
unmute. Alfred is here. He can chat if he wants. Alfred or Shinoj, I can unmute him and see if anybody wants to chat. Your team is here.
Yeah, and one thing. Sorry, Shinoj just mentioned to me via text that some of our users have been developing these systems for themselves, but they found it to be so time-consuming that they were very thankful that we've already gone ahead and implemented this, so they can just start using it.
Sure.
So that's one of the good feedbacks that we have received.
Yeah, it takes a lot of work to do it to develop yourself. So if there's something ready-made, why not use it? Yeah.
Staying up to date with HTML5, multiple labs, all that kind of thing is a major resource.
Another question: if you're looking for an optimum circuit solution for the desired output, would it be possible to do that? You want a desired output, but you want to know what's the circuit that will get you that output. How would you?
Okay, optimum circuit. So I'm not exactly sure what they mean. Do they want to build the circuit themselves, or do they just want to vary the parameters and study the performance of the circuit?
Yeah, I'm not sure. Anil, you want to chat? Let's see. I'm going to open up this guy who wants to. I'm going to unmute you, Anil. See what you have in mind.
I'll describe both options. If you want to study the if you want to describe the performance of a circuit, you can certainly do that.
He's saying vary parameters. He's saying, vary the parameters. That's what he's saying. Anyway, yeah.
Oh, absolutely. Yes, you can vary all the parameters of the circuit. Wherever you want to put a potentiometer, you can put it. So you have almost complete control over the circuit using switches and potentiometers. It's a very flexible system.
Good.
Hello. Yes.
Yes. So that's great. I think we haven't had too many more questions, and at least the responses to the polls were good. So it shows a high level of interest. I think, unfortunately, this week has been the kind of the week before classes start again next week. Probably there are a little less attendance in colleges. So, but it's exciting. How can Carlos? How can we help you further? How can we take this further? How can IUC help you move forward? Because that's what we would like to do as one of our corporate partners. We'd love to. Giving a webinar is fine, but I think there could be other things that maybe we could do with you. With some of our staff in Hyderabad helping you out, and stuff like that. What would be like?
I think more of these webinars where we're able to let people know that there is a solution already available that can meet their need, and so can save them time and money, and they can start educating their students remotely straight away. So building awareness, and I think these webinars are fantastic because it is a remote access tool, so accessing it remotely is no problem whatsoever.
So do you have a person running around in India, or how do you do sales and marketing in India?
Yeah, we have a company, EduTech, and it's quite a large company throughout India, and we can put you in touch with them. In fact, they would contact you if you're an end user, and you send us an email to monateams.com or netcircuitlabs.com. We can get in touch. Or Dr. Vidula, would you be able to supply us with the names of the people who attended the webinar? We would simply send them a follow-up.
We can do that, and not only that, we can send you some information about all the colleges that are members of our consortium. So you can contact even those who could not for various reasons. Some people may not be able to attend. I have recorded this webinar. I hope you don't mind. So I'll be sharing that also with the colleges. The recording of today's webinar, which will help others who could not come live to actually see what's going on. So that will be
because
I'll send you the link to that as well. Sridhar will convert it and send it to you.
All right. Okay. Thanks. And look, and just finally, I just want to say, typically a campus, a university will buy 3 or 4 base units from a certain provider, but this equipment is equal to the cost of 3 or 4 units, and you can supply all your students 24 hours a day, 7 days a week. So it really is an incredible cost benefit to have this remote access lab. So we're really excited about it throughout the world.
Mm-hmm. This is very good. Thank you for taking the time, Carlo, and also Sinoj and Alfred, who are here, and for all the participants who have stayed till the end. And really exciting stuff. I can see this is the future of of education. So we're just at the beginning stages, and I'm sure more exciting things will happen. And I'm sure your company will be leading some of these changes. So thank you so much. Appreciate it.
Thanks very much, Dr. And thank you for your initiatives in spreading the word of remote engineering throughout the world with your own endeavours, which are significant and very complicated. So much appreciated.
So I'm glad we were able to get an Australian company into our here. I think we met on ASEE last year, so that's great. Yeah, fantastic.
I mean, if you can access a lab and use it from Australia, you can pretty much access it from anywhere, right?
That's right, absolutely. So thank you so much again. Okay, and have a good day. Yeah.
Thanks, everybody.
Everybody.
Goodbye.